Okay. So here we have a completed. Now, no, sorry. Sorry, one minute. Yes, this is the paper. And we have to start from this part, right? Okay. Silver bromide, AgBr, dissolves in an aqueous solution of thiosulfate ions to form the complex ion. This, okay. The thiosulfate ion act as a monodentate ligand. Okay, that's fine. Now what they are asking you, define the term ligand. So I can define it as it is an ion of which shares a pair of electrons, or you can say lone pair, to form dative bond with the central metal atom. So it can be an ion or it can be a, an atom which have a lone pair of electron, and this lone pair of electron can be shared with the central metal ion to form a dative bond, then it's an ligand. Now, write the expression for the equilibrium constant Kc for equilibrium 1. Here we have equilibrium 1. If we write the Kc expression, it would be concentration of bromide ions times concentration of no. We have a concentration of this complex. Okay. So bromide ion times concentration of divided by, here we write the concentration of thiosulfate only, and we do not include raised to the power 2. We do not include this silver bromide because it's a solid. Okay. Then next part. Some additional data are given about dissolution of AgBr in S2O32 negative. Okay. KSP and K step. Okay. So if I look for a KSP expression, it would be like this, that Ag forming Ag positive ions and bromide negative ions. So the KSP expression would be concentration of Ag ions times concentration of bromide ions.
सर
Sorry?
सर मैंने ये पूछना था कि जो ऊपर केसी की हमने एक्सप्रेशन बनाया है उसके अंदर हमने AgBr क्यों नहीं लिखा नीचे?
Because it's a solid over here and is a square bracket refers to the concentration, and concentration is always for a solution when something is dissolved in water, then it forms a solution, and the concentration is always for a solution only.
Thank you, sir.
Okay. Now stability constant. If it's the stability constant value, so if we go for the first go for the equation for the stability constant, it would be like this, that we have Ag positive aqueous ions, and we have a 2 moles of thiosulfate ions forming the complex. Okay, it's 2 negative only. And here we got 3 negative. So if I go for the K-stab expression for this one, so the K-stab would be concentration of complex divided by concentration of Ag positive ions plus square of the concentration of thiosulfate ions. Is this understandable to everyone?
Yes, sir.
Use your answer to C2 and these data to calculate Kc for equilibrium 1. Include the units for Kc. Okay. So compare these two equations. See over here. As I have written down these equations, so I can easily relate these two, that basically Kp times K stab is equals to Kc. Okay. If you want to see how it is, see, if it's Ksp, then it's concentration of Ag positive ion times concentration of bromide ions multiply by, if it's a K stab, then the concentration of Ag S2O3 twice 3 negative divided by concentration of Ag positive and square of the concentration of S2O3 2 negative. So if you see this Ag and this Ag would going to be cancel out. Yes, is this clear? Now if you see, we are left with the bromide ion. Here we have a bromide ion. We were left with the concentration of the complex. Here there is a concentration of a complex, and we have the square of the concentration of thiosulfate S2O3 2 negative. Here we also have a constant square of the concentration of complex or thiosulfate, and we know both the values over here if you see. So I would first show what is Kc? That Kc is equals to Ksp times K step, and Ksp is 5.4 exponent minus 13 multiplied by K step is 2.9 exponent 13. Can anybody solve it and tell me the answer?
15.66.
15.66. Okay. So I can round off it to three significant figures when I have to write it. It could be 15.7. Okay. Now, the unit for Kc. So if you see over here, there is a one concentration, there is a second concentration, and there are two concentrations in the denominator. So if I displace all these with the mole per dm cube, so these are going to cancel out with each other. So hence we can say that there is no unit. Is this clear? Yes, is this clear to everyone?
Yes.
Okay. Now, the numerical values for the stability constant K step of the two other silver 1 complexes are given. Okay. An aqueous solution of Ag positive is added to a solution containing equal concentration of cyanide, ammonia, and thiosulfate. Okay. The mixture is left to reach equilibrium. Deduce the relative concentration of silver cyanide, silver amine or ammonia, and silver thiosulfate present in the resulting mixture. Explain your answer. Okay, so if you see, the K step value of this one would be the greatest. So it means it must be in the highest concentration in the equilibrium mixture. Then it is just 15.7, and amine have exponent minus 7. Sorry, exponent 7. So I can consider it have a moderate concentration of these complexes in its solution. But it's 15.7.
So we have to use the value of K step.
Yes, that is S2O3. This one.
This is the value
So,
of Kc.
yes, this is the, okay, sorry, yes, this is the value of Kc. So K step is, okay, 2.9 exponent 13. Let me write over here. 2.9 exponent 13. Okay, thank you, Ahmed. So it means the K step value of thiosulfate complex would be greater than ammonia. So it have a moderate concentration, which means its concentration must be highest than the ammonia complex concentration. And this one has the lowest concentration. Okay. Is this clear to everyone?
Sure.
Okay. So the complex having the highest concentration is silver with the cyanide, and the lowest concentration would silver with the ammonia, and thiosulfate would have a concentration, sorry, intermediate to these two. And the explanation for this is that the case tab value of
सर वो सेकंड और थर्ड आपने दोनों सेम ही लिख दी।
okay. Thank you. Its value is highest, and then I would write that the case tab value of AgNH3 twice is lowest. Okay. Is this clear to everyone?
Yes, sir.
Okay. Now, define the term lattice energy. So, it is the energy change, or you can say that it is the energy released when 1 mole of an ionic solid is formed from gaseous ions under standard conditions. Is this clear to everyone? Yes.
Sir.
यस सर।
Okay. Now, use following data to calculate a value for the enthalpy change of solution of copper 2 chloride, that is delta H SOL. You might find it helpful to construct an energy cycle. Okay. So we are provided with the hydrations and we are provided with the lattice energy. Okay. So if we make a, for example, if we make a cycle, you can make a Hess cycle or you can make a Born Haber cycle for this. So see, for example, if I form solid copper 2 chloride over here from gaseous ions, then I can call it the lattice energy, and its value is -2824 kilojoule per mole. Is it understandable? So on dissolving this copper chloride, we would get the aqueous copper chloride. So that is the enthalpy change of a solution, and that's what I have to find, right? And when these gaseous ions turns into copper chloride aqueous, that is the enthalpy change of a hydration. And here, as a copper ions are gaseous copper ions are getting dissolved, so its value would be minus 2999. And gaseous chloride ions are getting dissolved, and there are two chloride ions, so plus 2 times minus 378. Yes, is this cycle is understandable to everyone?
सर ये कॉपर क्लोराइड के हमें आयंस नहीं मिल सकते aqueous.
It doesn't matter, either you write CuCl2 aqueous or instead you write Cu2 positive plus 2Cl negative in aqueous state. Both means, both is refers to a same thing. Okay.
Yes sir.
Okay, so if we look at this equation, that if you see, this is the starting point, and from this, by enthalpy change of hydration, we are getting this in the single step. Otherwise, by lattice energy and then enthalpy change of solution, we are again coming in forming these two. 1 minute. In a two steps. So the expression would become minus 2099 plus 2 times minus 378 is equals to minus 2824 plus x, and x is the enthalpy change of a solution. So if I make the x subject, then it is minus 2099 plus 2 times minus 378 and plus 2824. Can anybody solve me and tell me the answer?
Negative 31.
Okay, so x is negative 31. So it means the enthalpy change of a solution of copper 2 chloride is minus 31 kilojoule per mole. Is this clear? Okay. The enthalpy change of hydration of calcium 2 positive ion is minus 1579 kilojoule per mole. Use the data booklet to suggest why there is a big difference in the values of enthalpy change of hydration of calcium and copper 2 positive. So what do you think, what we have to look in the data booklet for this? Or just think that enthalpy change of a hydration of Cu2 positive is minus 2099 kilojoule per mole, and the enthalpy change of hydration of of calcium would be minus 1579 kilojoule per mole. Yes, what could be the reason behind?
सर वो कॉपर ट्रांजिशन होता है, ट्रांजिशन एलिमेंट होता है,
So
तो उसका बॉइलिंग पॉइंट हायर होता है और
there is
वगैरह
nothing to
वगैरह.
do with the boiling point. We are talking about hydration. What hydration refers to? How do you explain hydration? We explain hydration as the gaseous ion turning into aqueous ion, right?
Yes sir.
That hydration means, so when it gets aqueous, So here there is a bonds formed between this ion and water molecules, right? So if its value is greater, which means stronger bonds are being formed, and if its value is smaller, then relatively weaker bond. I don't say that it is completely weak, but relatively weak bonds are formed, weaker bond. Okay. So if you look at their charges, both are of same charge. So this would help me to understand that copper to positive ion have that much size, then calcium to positive ion is probably have a that much size. So we can conclude from this. And if you look in the data booklet, and for this you have to refer to the previous data booklet, not the latest one, because in the previous data booklet you would find the ionic radii or ionic sizes. So we can say copper to positive ion is smaller in size than calcium to positive ion. Hence, the bonds between copper to positive and water molecules are stronger than between calcium to positive ion and water molecules. Yes, is this understandable to everyone?
Yes, sir.
Okay. If anybody have any doubt, kindly ask. 4B1, identify the substances formed at the anode and at the cathode during the electrolysis of calcium chloride aqueous. So if it's an aqueous, it means there is a calcium ion and a hydrogen ion, chloride ion, and hydroxide ion, right? So it's a saturated solution, which means that there are more chloride, concentration of chloride ion is greater. So chloride ion goes to the anode, and as hydrogen is lower in reactivity series, so instead calcium hydrogen would go at cathode. So we have to just identify the substance. So what would happen at anode? That chloride forms chlorine by leaving 2 electrons, so we need 2 chloride ions. So this is the substance that we are getting at anode. And at cathode, the hydrogen ion gains electron, forming hydrogen gas.
सर
Yes.
सैचुरेट का मतलब डाइल्यूट concentrated है.
Yes, because saturated, if the term saturated is written, then it means it is the solution in which there is a maximum capacity, maximum amount of the calcium chloride is dissolved. And if I try to add more calcium chloride in it, then it would not be dissolved. That's what saturated means, that it has a maximum capacity of a solute already dissolved in it. Is this clear?
सर तो फिर अगर concentrated है तो फिर जो anions है उनका हमेशा maximum होगा even hydroxide से भी.
Yes, that's why chloride goes.
सही है.
Otherwise, if it's a diluted solution, then instead chloride hydroxide would undergo oxidation at anode, forming oxygen gas.
Okay, sir.
Okay, so the products that I'm getting at anode is a chlorine gas, or I can write just chlorine, and here hydrogen. Okay, next part. I hope is yes, is this understandable? B1. Now B2. Calcium can produce by the electrolysis of molten calcium chloride. Okay, now see molten, and then the calcium is produced. So it means that when we use this molten, then at cathode, now there is no hydrogen. So at cathode, the calcium 2 positive ion gains 2 electron and form calcium metal. Calculate the mass in gram, okay, of calcium formed when a current of 0.75 ampere passes through calcium chloride for 60 minutes. Okay, so as I have made the equation, now I can easily, relate it that there are 2 moles of electron, which means 2 times 96500 coulomb charge is passed, and for that 1 mole of calcium is being formed, which means, let me just check, it's 40 or 40.1. I always get confused.
सर लिखा हुआ है उधर 40.1.
Okay, where it is? Okay, thank you. So it's a 40.1 gram of calcium is produced. Okay, then during the experiment, the coulomb charge that is passed is equals to basically 0.75 ampere current times 60 minutes, which I have to times it 60 to convert into a second. So this is the coulomb charge, and for that much coulomb charge, how much mass of calcium is produced? That would be X. So if I calculate the X, it would be 0.75 into 60 into 60 into 40.1 divided by 2 times 96500. So can anybody solve it and tell me the answer?
0.56.
So X is equals to 0.56 grams. So here we have a 0.56. Is this clear to everyone?
Yes, sir.
Next, C1. What is meant by the term entropy of a system? So we can say that entropy of a system is the degree of disorderness or degree of randomness of a system. Okay. Now, place one tick in each row of the table, show the sign of each entropy change. Dissolving sodium chloride in water, so a solid is turning into an aqueous state. So there is so much disorderness, increase in disorderness, so the change in entropy would be positive. Water is solidifying to ice, so a liquid is turning into a solid. So there must be a decrease in the disorderness, because in water the molecules are more disorder, and in solid the molecules are less disorder, so the delta S is negative. Is this clear?
Yes, sir.
Okay. Now, the evaporation of 1 mole of water has a standard Gibbs free energy delta G positive 8.6 kilojoule at 25 degrees Celsius. Okay. Sketch a graph on the axis to show that delta G changes for this process between 25 degrees Celsius to 150 degrees Celsius at 101 pascals. Okay. So think, we are talking about the standard Gibbs free energy for which process? Evaporation of water. So, for example, if the temperature is not 25 degrees Celsius, but it's 100 degrees Celsius, then the temperature, the evaporation occurs readily or with a difficulty? Yes.
Readily.
Sorry.
Readily. Will be easy
Readily.
to.
Yes, would be easy. So, and if you recall the 100 degrees Celsius temperature, isn't it the boiling point of water,
Yes.
right? So below that, above that boiling point, the evaporation occur more readily, right?
Yes.
And at below this boiling point, for example, at 99 degrees Celsius, the evaporation would occur, but would be occurring less difficult, less readily, or with a difficulty. So I can conclude that, for example, at 25 degrees Celsius, the entropy is positive 8.6. So let's consider this is 8.6. I'm just putting a point because it's a 25 degrees Celsius. So at 100 degrees Celsius, we know it's the boiling point. So where both the states coexist. So at 100 degrees Celsius, the Gibbs free energy must be zero, because here the reaction or the change is actually gets just feasible, right? So what we are observing that the Gibbs free energy is, lowering down, and obviously if at 100 degrees Celsius it's just zero, that at 150 degrees Celsius it must be have any negative value, right? Even more than this one. So these are the two things that you have to keep in mind, that at 25 and then at 100, okay, it would be, no, sorry, it would be a straight line, and in that straight line, that it crosses the x-axis from 100 degrees Celsius only. Okay, so I think I have to make it like this, then it would be more appropriate. Yes, it could be like this. Is it clear?
So why do we make a straight line?
Because entropy is the Gibbs free energy is gradually changing as the temperature changes. There is a direct relation. See, what is the expression? Delta G is equals to delta H minus T delta S, right?
Right.
So it is a direct relation.
Right. Okay.
Okay. Now, next part. The reaction between A and B is feasible at low temperatures, but is not feasible at high temperatures. Okay. Deduce the signs of delta H and delta S for this reaction and explain why the feasibility changes with the temperature. Okay, what they are saying, low temperatures, it's feasible, which means delta G must be negative, and not feasible at high temperatures, which means at higher temperature, delta G become positive, right? Is this understandable?
Sir.
Yes, sir.
Okay. So if you look at the Gibbs free energy expression, it is delta H minus T delta S. If I assume, because I have to assume and then identify whether what would be the case, that delta H is negative and entropy is also negative. So what would happen if the temperature is lower? Then think this value is smaller than delta H. If the temperature is lower, then this value is actually smaller than delta H, right? Are you getting this point?
Yes, sir.
And delta H is negative. So when we calculate it, the answer of a delta G must have a negative sign. Is this
Yes, sir.
understandable? I'm repeating again. See, this is negative, and when we put this negative value, then this whole term become positive, and delta G is still delta H is still negative. But at lower temperature, due to a lower temperature, the delta H would actually greater than T delta S. So on solving this, because it's a bigger value and this one is a smaller value, the answer would come with a negative sign, right? So at lower temperature, the Gibbs free energy is negative. Hence, we can say the reaction is feasible. Okay. Now, if the temperature is higher, then this would become greater than delta H, because if the temperature is getting higher, so T times delta S would be a greater value, and it's with a negative sign, and this whole become a positive. So when I solve it, I would get a Gibbs free energy with a positive sign now. So that is justifiable, that both, if both the entropy change and enthalpy change are negative, then at higher temperature the reaction is not feasible, and the lower temperature the reaction is feasible. So how could you explain this? You just write the expression to which would be helpful while making the reference or while stating the explanation. So we can write that at higher temperature T delta S is greater than delta H, hence delta G is positive. And then at lower temperature, delta H is greater than T delta S. Hence, delta G is negative. So we can conclude that as the temperature increases, the Gibbs free energy gets more positive. Yes, is this understandable to everyone?
Yes, sir.
Okay. Now we have question number 5. Okay. And the organic is started question. Describe and explain the relative basicities of phenylamine, ethylamine, and 4-nitrophenylamine. Okay. So phenylamine is this structure. Ethylamine is this structure. And 4-nitrophenylamine is this structure. So basicity, if you recall, it depends upon availability of lone pair. If a compound have a lone pair more readily available, then it is a stronger base, right? Because it can readily accept the H positive ion by sharing that lone pair. And if the lone pair is not available readily, then it cannot share its lone pair to the hydrogen and accept it. So its basic strength gets weaker. So if you see these three structures, here we have an alkyl group, which is electron donating in nature. So it induces its electron towards the nitrogen. So the electron charge density or the availability of lone pair is increased on this nitrogen. Phenylamine, that benzene ring is electron donating. So nitrogen electrons pair is induces to the benzene ring, which makes it a weaker base. And here, along with the benzene ring, we have another nitro group. So due to this nitro group, the electron withdrawing effect is more. The electron is withdrawn towards the benzene ring from the nitrogen of amine would be even greater. Hence, it have a very less likelihood to share a bond pair of, to share its lone pair to accept the hydrogen. So that's why it would be the weakest base or the least basic. So among these, I can comment that ethylamine is most basic. phenylamine have a basic strength moderate and 4-nitro phenylamine is least basic. Yes, is this clear for everyone? So it's for 4 marks. Okay. So first point, that the basicity depends upon the availability of lone pair of electrons to accept H positive ion by sharing its lone pair. That's what I have told you first, right? Now, in ethylamine, the ethyl group is electron donating, hence the lone pair is more readily available on nitrogen atom. In phenylamine, the lone pair of nitrogen is delocalized into benzene ring. Hence, its availability to accept H positive ion decreases, making it a weaker base. Last in nitro, sorry, it's in 4 nitro phenylamine nitro group also withdraws electrons. So the nitrogen, one minute. So the lone pair on nitrogen is even more less available to accept hydrogen ion. Yes, is this understandable to everyone?
सर
जी.
सर NO2 सेकंड या सिक्स पोजीशन पे लग सकता है?
When we have a phenylamine, yes, there is a possibility because 2, 4, and 6, because it's an electron donating the NH2 group. So it
तो
can be
अगर
attached.
सर ये तो अगर ये सेकंड या सिक्स पोजीशन पे लगा हो तो भी इसका इफेक्ट सेम ही रहेगा
Yes, the effect
जैसे
remains same
फोर्थ पे था.
because yes. Yes, the effect remains same. It withdraws electron. Okay, is
sir.
this clear to everyone?
Yes, sir.
Okay. The di-R can be synthesized from 4-nitrophenylamine in 2 steps. Okay. You deduce and draw the structure of the organic salt Q in the box. Okay. So basically Q is converting an intermediate which must be from this structure, and in step 2 this structure is introduced basically. So, and we have a nitrogen double bond which clearly indicating, and here we have a phenyl. Here phenyl and here nitrogen double bond. These two things clearly indicates that there is a diazonium salt made over here. So it would be like this only. And for this, if you recall the reagent, we would use NaNO2 and HCl below or equal to 10 degrees Celsius temperature. Now in step 2, it clearly shows that the reagent that I have introduced over here is basically this structure, and on this position of this, if you see like this, that diazonium salt is substituted. And so this is the one reagent, Okay, let's proceed further. Suggest the reagent and conditions in step 1 and step 2. So for step 1, we have mentioned the condition and the reagent that it is NaNO2 plus HCl, and temperature conditions are below and equal 10 degrees Celsius. Okay, so basically here we have a salt. So we have to remove the chloride from here, and for that we need an alkaline medium. This reaction occur in the alkaline condition. So you can use sodium hydroxide to show the alkaline condition. And if you recall this one, we have studied that we call it 1-naphthol. So our reagent is 1-naphthol. Is this clear? Now, next part. Compound G can be synthesized from methyl benzene in 3 steps. Okay, here we have a compound G. Okay, so we have to figure out E and F. So I think if I do the nitration of this methyl, as methyl is electron donating in nature, so the nitro group is going to be substitute on a second position. And if I further do the bromination, that methyl group, as it's electron donating in nature, it would substitute bromine over here. So it means now in the third stage, I have to do the oxidation. So here this is electrophilic substitution and here it is electrophilic substitution. So on oxidation, the methyl side chain turns into carboxylic acid. So let's put the reagents which are needed. So for this stage, we need concentrated sulfuric acid and concentrated nitric acid, and the temperature conditions are around 55 degrees Celsius. In step 2, I need a bromine with anhydrous AlBr3, and for oxidation of benzene, we need alkaline potassium manganate 7, and then heat it, and then we need to further acidify to convert the salt of carboxylic acid into carboxylic acid. So give the systematic name of compound G. Okay. So this is the first carbon, this is second, this is third, this is fourth. So it would be 4-bromo, 2-nitro, benzoic acid. Is this clear to everyone? Deduce and identify E and F and draw the structures in the boxes. So if you see, we already did it. Now what they are asking, suggest the reagents and conditions for each step 1, 2, 3 in C. Okay. So in step 1, as we have decided that we need concentrated sulfuric acid, which is our condition, and the reagent is concentrated nitric acid. In step 2, the reagent is Br3 and the condition is anhydrous AlBr3. So bromine and anhydrous AlBr3. Then step 3, as its oxidation. So either you write heat or you can instead write heating. Hot alkaline potassium manganate and then acidify. Yes, is this clear to everyone? Yes, is this clear to everyone? Okay. Question number 6. I think we should continue this question in our next class. And inshallah, I'll try to take the class tomorrow, hopefully. Okay. So see you everyone tomorrow. We will continue question 6 in the next class. Okay. Okay. Take care, everyone. Allah Hafiz.
Allah Hafiz, sir.